This is the NEX control kit, which comprises the Connect model here. This kit set builds 3 or 4 different models. In this case, a bascule bridge. NEX is a building system which most children in UK are familiar with, and also in America, because it comes from America. It's quite interesting in that it's different from Lego, which is a layered building system. It's different from Fisher Technic, which is a more engineering based system, as is Meccano. Here this NEX system builds a wireframe model, and here we have a bascule bridge with 2 bascules here. It has 2 motors controlling each bascule. There's also a sensor here in a green sensor container. This reacts to magnets, and the magnets are here, here, here and here. So when the sensor is next to a black magnet container, the sensor reads 1, and when it's not near 1, the sensor's reading 0. So it's like on and off. We also have a red light, green light and a buzzer, and they're down one end of the bridge, of course, to warn motorists not to go onto the bridge when it's open. The control system has to be controlled in this case by a control interface and software, and here we have the FlowGo, which is Data Harvest's own control interface. Very popular in schools, low cost but very powerful in that it's got 8 total inputs here, outputs, sorry, 2 motor outputs, and has 4 sensor inputs. It runs off a mains connector, or it can indeed run simply from a battery box. So once the program is downloaded to the FlowGo interface, it can run independently of any laptop or computer on which you may have devised the program. And of course, lastly, is the software itself. Software you probably won't see in this shot, so we'll show you in a minute. It's running a software called Go. I'll turn the laptop this way anyway, but I doubt whether you'll actually see that. Still, there we are. Go software is a very interesting evolution of control programming in education. It's taken a flowchart approach and focuses really on logic, sequencing, troubleshooting and so on. All the elements which are so important in children programming. Indeed, this whole scenario of control technology is I think a very important means of teaching programming to children and to students generally. Why? Because it focuses on real things in the world that kids are familiar with. In this case, they look at this bascule bridge and think, there's Tower Bridge, something of an image they're all familiar with, and they know how Tower Bridge works. Building it requires, and controlling it requires not only visual learning, kinesthetic learning and auditory learning. It also involves a lot of collaborative work as well in the building and the programming. It can all be done in a very structured sort of manner. So I think using control technology, for example, to teach children programming techniques and skills is a win-win situation for schools and for students.